Have you ever opened up an old computer, a broken remote control, or any device with exposed electronics, and noticed that the circuit board inside is almost always the same shade of green? Different manufacturers, different countries, different decades, and the color barely varies. You assumed green must do something specific: conduct heat better, signal a safety rating, relate to the electronics themselves. It does none of those things. And the most striking part of this story is that nobody currently working in the electronics industry can point to a single decision maker who chose it. The green does not come from the board material itself, typically a fiberglass composite that is naturally off-white or tan. The green comes from a separate layer applied on top, called solder mask, a thin protective coating painted over the board's copper wiring before components are attached. Solder mask serves a genuinely important function. It insulates the copper pathways from each other and protects the wiring from oxidation and from solder flowing where it shouldn't during assembly. The mask needs a color. It simply does not need to be green to do its job. But here's the surprising truth. Industry historians and electronics engineers researching this question consistently trace the green standard back to a specification used by the United States military in component manufacturing during the 1950s and 60s. Military procurement contracts required extremely consistent component quality, and the specific solder mask formulation that performed best under testing happened to be a particular green epoxy resin. Once that formulation became the documented standard for defense contracts, manufacturers supplying both military and civilian markets had every incentive to use the same proven chemistry rather than maintain separate testing for different colors. Think of it like a hospital choosing surgical gowns in a specific shade of blue-green decades ago, because that color reduced eye strain when staff looked away from a red surgical field, and every hospital afterward simply continuing to order the same color, not because anyone re-evaluated the original reasoning, but because changing it would mean justifying a switch nobody was asking for. So, if green carried no functional necessity beyond one military contract's specific chemistry, why has the entire global electronics industry, well beyond any military application, continued using it for 70 years? The answer, as is often the case with manufacturing standards, comes down to the overwhelming cost of coordinating a change that nobody individually benefits from. Once green solder mask became the most widely tested, most widely available, and most cheaply produced formulation at industrial scale, every other color became a custom order, carrying a price premium and a longer lead time. Engineers inspecting boards by eye also grew accustomed to spotting flaws against a consistent green background, building decades of visual habit around a color that began as an accident of one contract's chemistry. Other colors exist. Red, blue, and black solder masks are manufactured and used, particularly where a board will be visible, such as inside a transparent gaming console. But the default, the color used when nobody specifically requests something else, remains the same green a Cold War-era military specification happened to settle on, propagated since not by any law or technical requirement, but by the simple economic gravity of an established supply chain. So the next time you see the inside of a piece of electronics, you will know that the green you are looking at is not a property of computing. It is the surviving residue of one military contract's chemistry. Still the cheapest, easiest default 70 years after the war it was designed for has been over for generations.